Hello everyone, today we'll be covering the Logless Hunt TryHackMe walkthrough. We're going to learn how to detect every attack step on a Windows machine even after threat actors cleared security logs. So that being said, let's get started. And also, to speed up the walkthrough, I'm going to start the attack box now. Refresh, and also review the guide as well. So that being said, on the right, the attack box is starting. So let's start with Task 1 Introduction. In this room, as a DFIR team member, we will be tasked with supporting a medium-sized company in its efforts to investigate and recover from a cyber attack in which threat actors cleared Windows security logs and hoped to remain undetected. This room is intended for DFIR team members and SOC Level 2, Level 3 analysts who want to be better prepared during scenarios in which a cyber attack does not leave any obvious traces but still must be investigated using built-in tools and artifacts. Learning objectives: we're going to get acquainted with different Windows logs, some even more helpful than security logs. We're also going to investigate a realistic attack scenario from web exploitation up to credential access. Prerequisites: before moving on, it is recommended to be familiar with Windows OS, its logging capabilities, and common attack techniques. Great room to start with this is the log analysis module. In the Windows event logs, you can click on these to gain access to those rooms. And notice this room includes both guided walkthroughs along with independent challenges that rely on knowledge gained in other rooms, so prepare for both. So let's begin. If you click on the answer here, that will be green, so no answer needed. That's the correct answer. So we're going to move on to the scenario itself. All right. In this case, I just started the attack box because this is a good habit, because the attack box can take a while to start up. But in this case, we have a machine, so we're going to start the machine here. We're going to give it some time. There goes loading. While it's loading, we're going to discuss about the scenario. So in this task, we're going to cover the scenario. Customers CTO intro. Our IT team received an IPS alert on suspicious network behavior and began investigating. They reviewed the security and system logs on all our Windows servers included. All event logs are empty, so hackers did not breach the servers. But guess what? A few days later, our website started showing some crypto scam ads, and some servers were running at 100% CPU load. While our IT team is recovering the critical servers, can you look at our old HR server, HR01-SRV? We hosted salary review automations there that got unpopular, and the server is now rarely used. However, we noticed a spike in HTTP traffic from the user subnet and suspected to be part of the attack. We would appreciate seeing any advice you can find there. And here you can see the DMZ subnet, the port source HTTP 80, RDP3389, users allowed blocked, and DMZ allowed, and the user subnet on the right. So on the left, we have the DMZ subnet, and on the right, we have the user subnet, and also more information pertaining to the port source, users, and DMZ. All right, so we click on this. We now have our machine for this room. So that being said, before moving forward, we've already done this, but I'm going to explain the instructions in case you didn't do this already. Before moving forward, start the lab by clicking the Start Machine button above. It will take 2 minutes to load. We've already started the machine, but a button will be here to start the machine. It'll take around 2 minutes to load. The VM will be accessible on the right side of the split screen, which you can see here. Alternatively, you can connect directly to the machine using the following information via RDP. Username administrator, password admin123, IP, RDP 10.68.149.88. This can be different depending on what machine you get, but overall the username and the password in this information will show in this box here. After launching the VM, open Event Viewer. What is the earliest event ID you see in the security logs? So this is our question that we're being asked, which is to find what is the earliest event ID you see in the security logs. So we're going to click on, actually let me give you full screen, just to make it easier on the eyes. Let me click on Logless Hunt. And let me click on Search, Event Viewer. We're going to click on Event Viewer here. Sometimes it can be finicky, so we'll give it some time. There we go. The event viewer now starts. So in this case, we're trying to find the earliest event ID we see in the session in the security logs. Just going to click on Windows Logs Security. We're going to maximize this, make it easier on the eyes. Sometimes it can be finicky, so give some time to load. Maybe a refresh is needed in case. Okay, since I refresh, let me try to start Event Viewer again. There we go. Now let's click on Windows Logs Security. And now we have our logs. It just took a moment to load. So let me minimize, let me expand so that we can see all the logs. And then we're going to filter by the earliest date and time so that way we can see the first event. In the first event, we can see it was at 1:23/2025, 5:14:20 p.m. Source event log. Event ID is 1102, log clear. And the details can be found here. The audit log was cleared. Security ID, account name, domain name, and login ID. And if you don't know what event Windows log and security logs that we're looking at, give me 1 second. Don't worry, I'm going to help you out. Windows event logs. So, Windows Event Viewer is a built-in Windows tool that records detailed information about system security and application events, allowing users to troubleshoot issues or audit security. You can access it by typing event vwr.msc in the run box or searching Event Viewer in the start menu, which we did. There's also a video here for reference. And for the log types, to get more information pertaining to the logs that we're investigating, system records OS component events, drivers, service failures. Application records application-related events, software crashes, and security records auditing events like login failures and resource access. The event details, clicking in event reveals general information, which we've seen, with a details tab providing XML formatted data for advanced troubleshooting. And also you can filter by errors, you can check security logs, and you can check the setup logs as well. And also, since we're talking about event IDs, this is a really great resource to reference the Windows Security Log Encyclopedia. So we viewed 1102. So if you click on that, the audit log was cleared. You can see more information pertaining to it in terms of description fields, examples, seminars, and much, much more. So overall, I recommend bookmarking the Windows Security Log Encyclopedia website because it's going to help you better understand different Windows event IDs that you will see using Event Viewer. And also they're very detailed in terms of information such as on this page, description, field level details, examples, and much, much more. So that being said, the answer is 1102, and that is our answer. Moving on to task 3, initial access web access logs. Before I explain what is web access logs, I'm going to break down what is initial access. So in this case, we're now going to look at initial access. Initial access is the first stage in a cyber attack where threat actors gain unauthorized entry into a network, often using techniques like phishing, exploiting vulnerabilities, or using stolen credentials. Initial access brokers, IABs, frequently sell this entry to other malicious actors such as ransomware groups, forming a key part of the cybercrime as a service economy. And some common initial access techniques are phishing, exploiting public-facing applications, valid accounts, supply chain compromise, and external remote services. We're going to see some of these examples in this Logless Hunt room, so don't worry if you don't understand this right now. But I just want to expose you to this information so that way you understand, like from a foundational perspective, what is initial access. And some key concepts associated with initial access is initial access brokers, IABs, specialized criminals who breach networks and sell access to others, often for ransomware attacks. The MITRE ATT&CK framework is a comprehensive knowledge base detailing these techniques, cataloged under the initial access tactic. The reason why I mentioned that is because you can click on the initial access tactic from MITRE's website, and you can learn more about the attack, tactic and the techniques associated with it. You can think of the tactic as the what. What tactic is this? It's initial access, which is the adversary is trying to get into your network. The techniques would be the how. How did the attacker gain, or the adversary get into your network? Did they get in through content injection, drive-by compromise, exploit public-facing application, and much, much more? So overall, the MITRE attack framework is really great because it helps you better understand these different tactics and techniques that adversaries or attackers use. So in this case, we're learning about initial access. So that's why I wanted to provide you that information. So that way you better understand what is initial access. And I highly recommend bookmarking the MITRE attack framework because overall it's a really great resource to help you better understand different adversaries and attackers' tactics and techniques. So moving on to explaining web access logs. Web-based services are extremely popular and are the #1 target of most threat actors after exposed RDP, which stands for Remote Desktop Protocol. In Microsoft events, most web apps are behind IIS or Apache. Those are web services. Those are associated with web, which log incoming requests by default. These access logs provide crucial insight during the investigation of web attacks and can help if you are dealing with them. Examples are Microsoft Exchange, AD services, on-premise web apps, and millions of websites worldwide using IIS or Apache. The most crucial context you can get from these logs is source IP, timestamp, HTTP method, requested URL, and status code. And finally, the default location for these access logs is Apache and IIS. For Apache, you can find the logs for access, pertaining to access logs, in the C Apache 24 logs folder and directory. For IIS, go to the C directory, navigate to initpub, then logs, then log files, and then the name of the website. An example here shows you what those logs look like. For instance, we have the source IP, timestamp, HTTP method, requested URL, and the status code. So with this information in mind, can you now check for any suspicious web activity happening on HR01-SRV? So for the first question, I already completed this room, but don't worry, I'm going to still walk you through how to answer each of the questions. First, what is the title of the HR01-SRV web app hosted on 80 port? So that being said, we're going to click on the hint. We're going to access the app via your web browser. So we're going to click on this, and then we're going to click on Google Chrome. Let me full screen it. And our question is, what is the title of the HR01-SRV web app hosted on the 80 port? So we see a 10.10.147.5 IP. Let's see what that is. And -80. So we're going to navigate to 10.10.147.5 semicolon 80 because that's our web's port. We're going to click enter. What if I go to the THM attack box and try it there? Yes. I know what I did wrong. HTTP 10.10.147.5 80. All right, let me try TryHackMe just in case I'm not getting it right. Oh, the IP, let's try that. 10.65. You'll get this question right. So let me try this. You try 10.65.149.88.80. There you go. The IP of our website is 10.65.149.88. The web server port is 80. And the name of our website is Salary Raise Approver version 0.1. And that's our answer right here. Salary Raise Approver v0.1. We found it by navigating to the IP of the website and the port 80. And the title is Salary Raise Approver version 0.1. Next, which IP performed an extensive web scan on the HR01-SRV web app? So that being said, we must navigate to the logs. So we're going to C, open up File Explorer, navigate to Access Log, open it up. And we can see here, there's a lot of GET requests, which means that the attacker or adversary is trying to learn more about the environment, or in this case, the website. So that's why we see a lot of GET requests. That's for enumeration purposes, which is very suspicious. So we see a 10.10.23.190 IP. So that must be affiliated with the attacker, because the attacker or adversary is trying to learn more about the website so that way they can find an entry point or initial access, because the adversary is trying to use a web vulnerability to get into our environment. That's why we see posts right here, upload.php. Attackers like to exploit websites through web shells. You're going to learn more about this in the upcoming questions. But for this question, the answer is going to be 10.10.23.190, because we see a lot of GET requests, which means the attacker is doing a extensive web scan, or in this case, enumeration to learn more about our environment, or in this case, the website. So the answer is 10.10.23.190. Next, what is the absolute path to the file that the suspicious IP uploaded? It's going to be, with a hint, Apache web directory is C Apache 24 htdocs. In this case, it gave us a hint. Well, actually, it gave us two hints. The first hint is that the Apache web root directory is C-24 htdocs. And it's asking for the absolute path to the file that suspicious IP uploaded. So we're going to go back. We have our logs. We have the IP, which is here, and we have the file path, well, most of it, C Apache 24 web htdocs. That is Apache's web root directory. And we're looking for a file that is suspicious IP uploaded. The suspicious IP is 10.10.23.190. And we see there was a post, which means that they are getting information. If you don't know about the different HTTP methods, let me help you out. HTTP methods. Let me get you a really nice image. All right, so post. Post is used to send data to a server to create a new resource. The data is included in the body of the request. Get, we're retrieving data from the server. So these are the top 9 HTTP request methods that I highly recommend bookmarking or learning more about. In this case, we're looking for post, because that means that the adversary or attacker uploaded a file to the website. So in this case, we're looking for post request methods. So looking for post, and we see here that there's a post request for upload.php. And it was successful because we see a 200 status code. For information regarding HTTP status codes, don't worry. Let me get you a nice image so that we better understand it. Yes. Actually, no, let me go back. This one's better. All right, so for 200, there's a multitude of different HTTP status codes, but don't worry. Let me break it down. For any status code that starts with 1 followed by XX, any digit, it's for informational purposes. For example, 100 is continue. Any HTTP status codes that start with 2 and are followed by digits, 00 in this case, success, 200, okay. For 3s, XX, any digits, for redirection, example, 300 multiple choices, or 301 move permanently. Any status codes that start with 4 and followed by digits, such as, for example, like 00, is client errors, bad request, for example. And finally, for any status codes that start with 5 and followed by any digits like 00, that's server errors. So hopefully now you better understand what is HTTP request methods and HTTP status codes, because we are reviewing web access logs. So it's important to understand this information so that way you better understand overall what the logs are and are able to spot abnormal activity in the logs. So for this question, we see a upload.php file but in this case, we're looking for the absolute path. So we're looking for uploads because that's going to be the directory that the file was uploaded to. In this case, we see post uploads search.php. And our answer is going to be C Apache 24 htdocs uploads search.php. That is our answer. Next. Clearly that's suspicious. What would you call the uploaded malware or backdoor? We have a hint. Note how the file is then repeatedly used by the attacker to achieve code execution. So we're going to search for that. I'm going to go to all. What is a file that would be categorized as uploaded malware or backdoor for an adversary or attacker to execute to used by the attacker to achieve code execution. As an attacker to achieve code execution. A highly common file categorized as an uploaded backdoor is a web shell. Examples are shell.php, which we saw, command.jsp, or backdoor.aspx, which allows attackers to execute system commands remotely. Other examples include malicious executable payloads such as .exe, .eof, for script files, .py, Python, .pl, or obfuscated office documents, .docm, designed to execute malicious code via macros or system vulnerabilities. And the common file types used for code execution can be found here: web shells, malicious script files, malicious executables, document files or macros, shortcut link files, and container files. And how they are used can be unrestricted file upload, which we saw with the upload details in the logs, remote file inclusion, or obfuscation. And we can click on the MITRE link for user execution malicious file. And then we can search for web shell. Load more results. Server behavior and file execution chains detected. But in this case, we found that it was a web shell. And if we wanted to see the actual MITRE attack information, we can do web shell MITRE attack. Server software component web shell. Adversaries may backdoor web servers with web shells to establish persistent access to systems. A web shell is a web script, which we saw .php for example, that is placed on an openly accessible web server to allow an adversary to access the web server as a gateway into a network. A web shell may provide a set of functions to execute or a command line interface on the system that hosts the web server. That is the tactic. Here are some examples below. So for this question, the answer is going to be web shell. Web shell. Moving on to task 4, from web to RDP PowerShell logs. Next, we're going to look at PowerShell logs. PowerShell logs are often underrated, although they can provide vital insights into threat actors' activity. EDR solutions, endpoint detection and response for instance, tend to block common malware, and simple CMD command prompt is not powerful enough for exploitation needs. PowerShell is becoming increasingly popular, mainly because of the popularity of so-called fileless attacks. There are 3 common PowerShell logging sources. The first one is console history file. Let me explain. PowerShell analog of bash.history in bash history in Linux. Enabled by default, it logs every command interactively entered in the PowerShell window, but does not log windowless commands that occur during web shell usage or RC exploitation. While code execution, and the image below shows how interactively enter PowerShell commands are logged to the history text file. So we can take this file path, we can copy it. So let me just grab all this. And just do a command C, go back, exit out of this, minimize this, bring up our trusty file explorer, take out the event viewer open, and let's navigate to our file path. In this case, it's not letting me do that. Just control Command C, just do Command V. Okay, I'm gonna have to type it out. We do app data, then dash Microsoft. There we go. Next, Windows, PowerShell, PS redline. And we can see our console host history.txt file here. More information regarding what this means will come in the upcoming rooms. But just for now, this is what a history.txt file looks like to help us better understand interactively enter PowerShell commands that are logged to this text file. What is a Windows PowerShell event channel? Let me explain. Enabled by default, it generates event ID 600 every time the PowerShell provider is launched and puts launch arguments in the host application field, which you can see here. And you can see the arguments, .-c for instance. In contrast to the console host history file, which we saw previously, it logs only the creation of the PowerShell console, but won't show any other commands launched within the same PowerShell session. Below, you can see how we launch a PowerShell engine, and its launch arguments will be logged with event ID 600. And in order for us to find those logs, we can use the event viewer. Let me minimize this. Navigate to Application and Services Logs. Click on Windows PowerShell. And click on one of these, for example. And we can see the host application field here. So our event ID 600 and overall the Windows PowerShell event channel, I want you to understand that this event ID only logs the creation of the PowerShell console, but won't show any other commands launched within the same PowerShell session. Last but not least, the PowerShell script block logging. While disabled by default, you may follow Microsoft's documentation to enable script block logging. You can access the Microsoft documentation by clicking on here and see the valuable event ID 4104 that logs every PowerShell command in full and decoded form. This event ID combines the power of basic PowerShell logging and console host history as it detects commands entered through script files, interactively or obfuscated via base64. Below, you can see how 4104, which is the event ID, exposes the content of PowerShell scripts. So to access these logs, we go to Event Viewer, we click on Apps and Services, which is the Application and Services logs. Then we navigate to Microsoft, in this case. Then we navigate to Windows. Then we scroll down to PowerShell, right here. And then we click on Operational, and we can see, let me give an example, right here. 4104, and we can see in the path, script block ID. Let me make this easier on the eyes by clicking on Details, and we can see the script block text information. Also message total, message number, event data. And for system information, we can just expand that. And we can see this is event ID 4104. And it shows us the script block text information. So just a quick summary, script block logging will show every PowerShell command in full and decoded form, and it combines the power of basic PowerShell logging and console host history because it detects commands entered through script files interactively or obfuscated via base64. And finally, it exposes the content of PowerShell scripts as well. All right, with that being said, you can view this information here. Let's begin by answering the questions. So, what did the attacker enter through their backdoor web terminal? Perhaps some PowerShell commands? That being said, let's move on to the questions. So the first question is asking us, what was the first command entered by the attacker? So in order to get this answer, we're going to look for event ID 600 events. So we're going to use the event viewer, but in this case, we're going to use event ID 600. So let me minimize this to make it easier. We're going to go to Windows PowerShell to see 600 commands. To 600 events, my bad. We're going to use find or filter. We're going to use filter in this case. We're going to type in 600. And we're going to filter the date and time to see the most earliest events. There we go. Now that we have that filtered, we're going to look for PowerShell-C events. PowerShell-C, find next. We got one here. The reason why I mentioned PowerShell-C is because the -C stands for command. In this case, we're looking for the first command entered by the attacker, so that's why I filter for PowerShell-C events. So if I maximize this, we're going to see -C, which stands for command, and the first command entered by the attacker was who am I? Because if I do a find, and then I do a find next, the first command is who am I, and next. Well, it's going to be who am I the next event, but overall the answer for this question is going to be who am I. Another answer. Next, what is the full URL of the file that the attacker attempted to download? In this case, we're going to go back. We're going to search for the IP. So we're going to do a find. Instead of PowerShell.c, we're going to look for the suspicious IP because that's the attacker's IP. Do find next. And we can see that there's a URL here. 8080 is another web port to know. And we see that there is a http-proxy.exe file. So in this case, the full URL of the file that the attacker attempted to download, because we found in a previous task that the 10.10.23.190 was the attacker's IP. The file that they are trying to download is httpd-proxy.exe, which we can see here in the logs. They're trying to run a command to download this httpd-proxy.exe file to this directory. Next, what command was run to execute the file from Windows Defender? So in this case, we're still going to look at event ID 600 events, but in this case, we're going to search for, we're going to do find. We're going to search for add MP preference -exclusion path events. Let me explain. So what this means is that an attacker is trying to exclude a file from Windows Defender. So that's why the exclusion path is here. And we can see it's C:/Apache24. And that is our answer right here. But the full command is going to be add-mp preference-exclusion path and the file path here. And we have -C To clarify, this is a command using PowerShell. And this is our answer: add.np preference exclusion path C Apache 24. Finally, which remote access service was tunneled using the uploaded binary? So we're looking for remote access services. For this one, we're going to look for, we're still going to use event 600, but we're going to look for RDP events. The reason why I mentioned RDP is because it's a very common remote access service commonly abused by attackers. So in this case, we're going to look for RDP events, but if we don't find RDP events, which we are not seeing here, we can use the port for RDP, so which is 3389. Find next. Here we go. We can see the command that the attacker is trying to use, PowerShell. We see the suspicious attacker IP and another web port 443. R stands for RDP, and the port is 3389. So for this question, which remote access service was tunneled using the uploaded binary? It's RDP. Next, breached admin RDP session logs. So the most common way to view RDP logs is to filter for event ID 4624 or fixed 4625 failures. 4624 for clarification is successful logins. 4625 is for unsuccessful logins, so just failures. And look for login type 10. The only issue is that this code is generated in the security channel, which is unavailable in this DFIR project. However, the good news is that there is a dedicated channel to track RDP sessions in a simpler format and with little noise. The RDP event channel is enabled by default, but note that only successful RDP logins are logged. In this case, event ID 21 marks successful RDP connect, 24 marks disconnect, and 25 marks reconnect. Every log contains 3 key fields. The first is user, the one that performed the login log off, session ID that you can use to correlate logins and logoffs, and third, source network address, source IP from where the login was made. The image below shows the log that will be generated immediately after you log into the VM via RDP. So looking for event viewer. In order to see these logs, we're going to click on event viewer, application, and services logs. Application and services logs. We're going to go to Microsoft. We're going to click on Windows. We're going to click on Terminal Services - Local Session Manager. So we're going to look for Terminal Services - Local Session Manager. Then we're going to click on Operational. And we can see here, this is our RDP logs. So in this case, let's click on 25. Remote desktop services session reconnection succeeded. Because 25 marks reconnect, so we're seeing a reconnection succeeded event here. So next, note that the source network address can also take an unusual local value that indicates local login and can occur during system startup and usage of hypervisor utilities. With the RDP port now tunneled, which we found in the previous task, and available from the user's network, can you trace its further usage? Yes, we can. So in this case, first, we're looking for the timestamp of the first suspicious RDP login, but we need to put the answer in this format here. So in this case, for successful RDP logins, we need to look for 21 events. Event ID 21 events. So first, let me filter this so that way we have the earliest events listed here. And we're looking for 21 as the event ID. And we can see there's a source network address, but we're looking for a event that has the attacker's IP, which is 10.10.23.190. So we're going to click on the next one. and we can see that a remote desktop services session login was succeeded. And we can see here that it was the attacker's IP. So the attacker logged in successfully as this user here. The answer is going to be 123.2025, or in this case, 2025-01-23, 5:12 p.m. In this case, it's going to be 12 plus 5, which was 17-00-12 as your answer. And the user that the attacker breached was HR01-SRV administrator, which we found here as well. Next, we're looking for the IP, which was the source of the RDP login, which we can also find here, which is 10.10.23.190, which is the adversary's or attacker's IP. And now we're going to look for, and finally, we're going to look for what is the timestamp when the attacker disconnected from RDP. So in this case, we're going to look for event ID 24 events because 24 marks disconnect. So we're going to filter by 24 instead of 21. We're going to filter, it's already filtered, and we're looking for a event with the attacker's IP. So now that we have the events filtered via event ID 24, we're going to find the event with the attacker's IP, which we can find here. The attacker's IP and the user that was breached, and the date and time is going to be 2025-01-23, 5:16:46 p.m. In this case, it's going to be 17:16:46. Moving on. Task 6. Persistent traces and scheduled tasks. Let me explain first what persistence is. So pertaining to persistence, okay. So persistence refers to techniques used by adversaries to maintain access to systems, ensuring their presence persists through reboots, credential changes, or other interruptions. It is a critical post-compromise tactic spanning techniques like scheduled test job, which we're going to learn in the current task, that enables long-term ongoing access to a target environment. Some techniques that is very important to understand is account manipulation, boot or login RL start execution, schedule task job, create a modified system process, and valid accounts. And you can use the attack framework to identify these behaviors rather than relying on static signatures. So if I click on the minor attack persistence link, I am directed here. And overall persistence is the adversary or attacker is trying to maintain their foothold. And persistence consists of techniques that adversaries use to keep access to systems across restarts, training credentials, or other interruptions that could cut off their access. And techniques used for persistence include any access, action, or configuration changes that let them maintain their foothold on systems, such as replacing or hijacking legitimate code or adding startup code. Now that we have covered what persistence is, we're now going to start this task. So task schedule logs. You may know that scheduled task creation is conveniently logged as event ID 4698 into the security channel, but there is also a dedicated log source made specifically to track every task execution, creation, or modification. Although the task schedule log channel is disabled by default, it is common to see it enabled, as IT administrators often use it to debug their scheduled tasks. For example, log event ID 106 is for task creation, event ID 100 is for task startup, and event ID 129 is for immediately after the task's process creation. You can read more about these other events in Microsoft documentation, which you can access right here by clicking on it. But the example below is for the task registration, which is 106, because that is for task creation. And to see those events, we can go to Event Viewer, go to Apps and Services Logs, click on Microsoft, and go to Windows, scroll down until we see Task Scheduler, and then click on Operational. And we can see here events associated with scheduled tasks. There we go. All right. If a deeper investigation is required, you may correlate these sources to get the full context of any existing task. Task schedule logs, task XML, task scheduler, and PowerShell or process creation log shack. Next, RDP tunneling was temporary. Did the attacker try to establish their tunnel in a reliable way? So that being said, let's start answering the questions. So, what is the name of the suspicious scheduled task? So we're going to go here. We're going to filter these events by earliest. So I get the earliest events. Nice. And we're going to look for the name of suspicious scheduled task. So in this case, we're going to look for task creation events because we're looking for the task itself. So we're going to look for 106 events. Yes. Or in this case, however, there is another way in order for us to understand task schedule events. We're going to use the GUI, Task Schedule Desktop App. We're going to maximize this. We're going to click on Task Schedule Library, and we see a suspicious Apache proxy task, which is currently running. And we see that the author is the HR01-SRV/administrator user, which in a previous task, the attacker breached that account. So this is the attacker themselves. And we can see the timestamp was around when that activity occurred. So the Apache proxy task is the answer, which stands for, which you can find here, Apache proxy. Next, when was the suspicious scheduled task created? So now we're looking for scheduled task creation events. So looking for event ID 106 events. So instead of the GUI, let me see if I can find the task started, task created. Oh, here we go. Task registered, Apache proxy. That was on 1/23/2025, 5:05:37 p.m. In this case, it's going to be 2025-01-23. And 12 plus 5 is 17. -05-37 is our answer. Next, what is the task's trigger value as shown in Task Schedule GUI? So using the GUI, we're going to go to Triggers. We're going to click at System Startup, which is the value right here. So in this case, our answer is going to be at System Startup because we looked at the trigger tab and found that the details was at System Startup, which is going to be the value for the trigger for the task. At System Startup is your answer. Next, what is the full command line of the malicious task? In this case, we're going to go to Actions, and we can see here, these are the details here. So the action is to start a program, and we can see it's C Apache 24 bin httpd-proxy.exe client, the suspicious IP of the attacker, RDP 3389. So in this case, what the attacker is trying to do is that at system startup, there's a specific action to start a program, which is the malicious program here, httpd-proxy.exe, associated with the suspicious IP and RDP because 3389 is a port for RDP. So for this question, the answer is going to be C Apache 24 bin httpd-proxy.exe, and then the rest of the information, which you can copy and paste as your answer. Moving on. For task 7, we're going to look at credential access events. So let me break down what credential access is. For background information, I'm going to go AI mode so that way you can better understand what it is. All right. In the minor attack framework and overall, credential access is a tactical goal where adversaries attempt to steal account names, passwords, tokens, or other secrets to gain unauthorized access to resources. By obtaining valid credentials, attackers can assume the identity of a legitimate account, inherit its permissions, and blend into normal network activity, making them significantly harder to detect. And some common techniques to know is brute forcing, OS credential dumping, stealing web session cookies, unsecured credentials, and credentials from password stores. And some mitigation strategies can be listed here, such as MFA, credential access protection, credential access policies, and finally, password policies. So overall, that's what I wanted to share, because even though it's important to understand the task, it's also important to have this kind of background information so that way you overall better understand the concept pertaining to the task itself. So, what is credential access? It's a tactical goal where adversaries attempt to steal account names, passwords, tokens, or other secrets to gain unauthorized access to resources. And if we click on this link, it goes to minor attack. But in this case, we can click on credential access, and we can see here the adversary is trying to steal account names and passwords, which is credential access. And overall, credential access consists of techniques for stealing credentials like account names and passwords. And techniques used to get credentials include key logging or credential dumping. Using legitimate credentials can give adversaries access to systems, making them harder to detect, and provide the opportunity to create more accounts to achieve their goals. And some techniques that attackers use for, or adversaries use for credential access is, and can be found. With that being said, let's move on to the task itself. So pertaining to credential access, we're going to talk about Windows Defender. So in this case, let's begin. Windows Defender logs. Even though Windows Defender is not bulletproof anti-malware protection, it can often help you detect malicious presence. If threat actors forget to obfuscate their malware, download the tools directly from GitHub, decide to create AV exclusion preemptively, or simply disable the engine. Then there is great news for blue team, since every Windows Defender detection or configuration change is logged. And you see the information, you can click here. Windows Defender event channel is enabled by default. For instance, there is logs with the event ID 1116 whenever any threat is detected, and 1117 when remediated, and 5001 whenever protection engines are disabled. 5007 and 5013 upon modification of its settings or exclusion creation. The example below, right here, shows the detection of Mimikatz launched from PowerShell. So if you don't know what Mimikatz is, let me explain. And this is for educational purposes because Mimikatz is also used by attackers. So we're going to ask AI, what is Mimikatz? And Mimikatz is a powerful open source post-exploitation tool primarily used to extract authentication credentials from Windows systems. And to learn how it works, you can read this below. So how it works is it specifically targets the local security authority subsystem service LSASS process, which stores sensitive credential material to enable sign on, SSO, and avoid reprompting users for passwords. Again, this is for educational purposes, so that way you better understand what Mimikatz is. So you can view its information here. But overall, Mimikatz is a tool used to extract authentication credentials from Windows systems. In order to see those kind of logs, we can go to Event Viewer. We're going to close out of Set Schedule. We're going to go to Apps and Services Logs. We're going to click on Microsoft, Windows Defender in this case. So we're going to scroll down to Windows Defender and click on Operational. And here we can see events associated with every Windows Defender detection and configuration change. And depending on the detection context, threat detection events may contain these fields, such as path file, path web file, name, the process name, and the user. Also, note that the mentioned Windows Defender event logs and threat detection history you see in the graphical interface do not depend on each other. To remove detection traces, threat actors have to both delete the event logs and delete database entries used by the graphical interface, which can be found at the file path C program data, Microsoft Windows, Defender, scans, history, service detection history, and its structure and content are beyond the scope of this room, but there's a good SANS blog post explaining this in detail, which you can access here by clicking on it. So it looks like the attacker went too reckless with reliable persistence. Really caught by the antivirus. With this information, let's now answer the questions. First, what is the threat family name of the first quarantine file? So in this case, we're going to use event ID 1116 because we're looking for threat detection events. However, we can also look at 1117 events because it mentions first quarantine file, which means that a file was found as being malicious and was quarantined or remediated. So we're going to look at 1117 event ID events. And let me sort these by earliest events. So 4:57, 4 p.m. There we go. And the name is going to be Vital Win64 Chisel.d because what this event means is that Microsoft Defender Antivirus has taken action to protect this machine from malware or other potentially unwanted software. And you can click here to learn more about it. So in this case, the answer is going to be Vital Win64 Chisel.g. And that's our answer. Next. And what is the threat family of the next detected malware? So we found the name, but we're looking for now the next detected malware and its threat family name. So in this case, we're going to click on the next one. And we see there's a hack tool Win32 Mimikatz PZ name. Because we're looking at 1117 events, this means that a threat or malware, potentially unwanted software, was detected and remediated. So it was detected. We can also look at 1116 events because that's going to show us threat detection events. And it's already filtered by earliest, which is awesome. So in this case, it's going to be hack tool Win32 Mimikatz PZ as our answer. Next, what is the file name of the downloaded Mimikatz executable? It's going to be mimi.exe, which can be found here as the path. And finally, which Mimikatz command was used to extract hashes from LSASS memory? If you don't know what LSASS memory is, don't worry. LSASS stands for Local Security Authority Subsystem Service, which, for more information, what is Local Security Authority Subsystem Service, LASS memory. So Local Security Authority Subsystem Service memory is the working memory space of the LSASS.exe process, which serves as the core of Windows security architecture. For instance, when you log into Windows, LSASS verifies your identity and then stores various forms of your credentials in its active memory to enable single sign-on SSO. And this allows you to access network shares, email, and other resources without re-entering your password for every new connection. So overall, when you think of LSASS memory, think of it as a core feature of the Windows security architecture and dealing with credentials in active memory pertaining to Windows systems. Because, another good point, LSASS proves your identity to different services. And the reason being that attacker is targeted is because it often contains credentials for multiple users, including those of domain administrators who may have logged into the machine previously. So with that information, we're now going to look for the command used by Mimikatz to extract hashes from LSASS memory. So we're going to go back. We're going to look at console history.txt because if we go back to task, scroll back, yes. Looking for task 3, no, task 4, yes. The console history file logs every command interactively entered in the PowerShell window, but does not log windowless commands that occur during web shell or RCE exploitation. In this case, we're looking for events associated with Mimikatz commands. So we're going to look for the console history file and logs indicating commands used by Mimikatz used with PowerShell. But more specifically, ones used to extract hashes from LASS memory. So we're going to use the console history.txt file because of that. And we can see here that the mimi.exe, which is associated with Mimikatz, used this command, privilege debug lsa dump semicolon lsa inject exit. Let's copy this and then bring it here and type, what does this mean? And let's paste it. This is a sequence of commands by Mimikatz used to extract secrets, like passwords and hashes from a Windows machine memory. Each part of the command performs a specific step in the credential theft process. For instance, privilege debug. This attempts to give the Mimikatz process debug privileges. Next, LSA dump, semicolon LSA. This tells Mimikatz to extract security data from the local security authority. Next, inject. This is a specific flag that tells Mimikatz to inject its own code directly into the LSAS.exe process memory to retrieve the secrets. And finally, exit. This simply closes the Mimikatz program immediately after the commands have finished running. So overall, what this command does is that it extracts secrets or passwords or hashes from a Windows machine's memory. So this information, the answer is going to be LSA dump, semicolon, LSA inject. And moving on to task 8, conclusion. And what was next? What did the adversary find in the Mimikatz dump? Was there any further lateral movement? Likely yes. But for now, let's return to the customer and see what they can say about the findings on our HR01-SRV. Also, other servers have already recovered, and there will be much more work to do soon, perhaps without any logs at all. In summary, in this room we covered basics of web access logs, and they're used in detecting web shell usage, upload, and usage. 3 types of PowerShell logs, their differences, and use in tracking malicious actions. RDP session logs as a simpler, more compact alternative to the security 4624 event ID. Task schedule logs, they're used to build execution timeline of scheduled tasks. And finally, Windows Defender logs, they're used in malware detection and classification. And for the question for this task, we can just click on this, and this will complete the room. So of all the tasks completed, let me share some more information. But overall, we have completed the room. It has 8 tasks, and we covered everything. So let me get to the information to close out this session real quick. But hopefully you enjoyed this walkthrough pertaining to Logless Hunt. Hope you guys enjoyed this session today. I'll see you guys in the next one. Peace.